What's going on, friends? In this one, we are going to build a full stack video and audio compressor app. The dashboard shows the statistics of user uploads, compressed, failed, and in progress. We can decide to navigate to different tabs on the dashboard. As you can see, we have the original size and the new size after a file has been compressed. This is amazing, from 36.6 megabytes to 2.5 megabytes. If the file uploaded is a video, we automatically generate a 10-second preview of the video. Thumbnails are also generated for videos. The duration shows the length of an uploaded file. We can also choose to upload a new video or audio. Let me select a file small in size. The dashboard is automatically updated once the file has been uploaded. Let's see a 10 seconds preview of the video. As you can see, this is a 10-second preview of the video. Let's also check out the generated thumbnail. This is the thumbnail generated from the video. The backend is powered by Django, Django REST Framework, S3 bucket, Celery, Docker, and so on. As for the front end, we really want to keep things simple. The front end is built with Vuejs and VueRouter. Friends, there is a lot we want to cover, and I can't wait to see you dive in. Kindly subscribe to the channel and give me a thumbs up so I can keep posting project-based tutorials like this. Thanks. Alright friends, the approach we want to take is an API-first approach. What that means is that we are going to build out the APIs needed before moving to any front-end integrations. For the backend, I have created a starter template needed to follow along. Make sure to visit the GitHub repository to clone the starter template to your local machine. This diagram shows the architecture of what we want to build. When the user submits a video or audio to the app, the backend performs necessary operations and uploads the media to S3 buckets. We immediately notify the user that the file has been uploaded successfully. Now for the compression part, we push the compression process to a worker. The worker retrieves the file from S3 bucket and begins the compression. Essentially, you use this type of design whenever you need to perform heavy computations. Now let's get started. Alright friends, right here on my local machine, I have cloned the starter template. Before we dive in deeper, I want to quickly explain what we have in the starter template. We have the Docker Compose file, which is used to run the application. The first service is the API service. The API service is using a Docker file, which can be found in this location, Docker, def, and the Docker file. In this Docker file, we are pulling the Python official image. We installed the required dependencies, and also we specify a bash script that runs the migrate command in Django. The API service depends on another service called DB. This DB service is the PosgreSQL database we are going to use. These are the environment variables. Next, we have the Celery service. The Celery service is inheriting configurations from the API service. Celery is particularly useful for long-running or resource-intensive tasks. This is the actual command for starting Celery worker process, but we need to use the watch files package so that Celery can support auto-reload. Next, we have the RabbitMQ service. For Celery to function as expected, we need a message broker such as Redis, RabbitMQ, and so on. Another service I need to mention is the Flower service, which is the dashboard service. Flower is used to monitor tasks we intend to push to Celery. Now let's move on to check what we have in the requirements folder. Django Storages provides a way for user uploaded files to be stored in cloud storages like AWS S3 bucket. Django REST Framework is for building the APIs. DRF Spectacular is used for generating the API documentation. Then this library is needed to connect to the PosgreSQL database. Let me show you a couple of things I have included in the settings file. First is the configurations for Celery. We've specified the broker URL as the RabbitMQ URL. We are using config to read the environment variables declared in the .env file. For the application to be able to communicate with AWS, we need to specify these two credentials, access key ID and secret access key. I will show you how to get those credentials when we need them. For now, let's leave them like this. Then we have the storage bucket. S3 bucket is like a folder or directory for storing files. For now, you can leave it as your name of choice. If you want to know more about these settings, I will put a link in the description below. Media URL is how the URL of a file uploaded will look like. We also have default file storage. We've specified that the location should be media and file should not be overwritten. This means if we upload a file with the same name, a random string is auto-generated to prevent file overwriting. We also mentioned that the file should be publicly available. The next thing I want to do now before the actual coding is to create a .env file where the application secrets can be kept. Touch.env. Now let's copy the content of .env sample and let's put it in the .env file created. Alright friends, now let's move on. Let's begin by running the application in a Docker container. I'm going to open up the terminal. See the desktop. Now let's build and start the Docker container. Docker compose build. This could take a while depending on how strong your internet connection is. If you notice, the API service is running the Django development server, which is this URL. We can visit the website by using this URL. Also, let's confirm if the RabbitMQ setup is working as expected. As you can see, the Rabbit user is authenticated, which means the RabbitMQ URL is working as expected. Now let's access the API, the Swagger documentation on this URL. Great, we can access the documentation. Another thing we want to check now is the Flower dashboard. The dashboard is running on this port. This port outside of the container is mapped to this port in the container. So we can access the Flower dashboard on this port. Let's copy this port. Now let's visit the URL again on this port. So now let's check the env. The username is admin while the password is password. Let's try that out. Admin and password. Great. If you don't see this online status, it means that Flower is not able to connect to the specified broker URL. The next thing we want to do now is to create our first app. So let's open up a new terminal. Docker compose exec API Python manage.py start app compressor, which is the name of the app. We are using Docker compose exec to run this command inside the API service. Let's confirm if a new app has been created. As you can see, we now have a new app named Compressor. What we are going to do now is to register this app inside the settings file. We need to look for installed app. We need to specify the new app, Compressor. Let's start defining the database models for the app. The first thing I want to do is to import the base model from the common package. Whenever you set abstract class to be true, it means that the model is intended to be used as a base model for other models. Let's go into the models module to make use of the base class from common.models import auditable models. So now let's create the media file models class media file. This class inherits from the base model auditable model. The first field we want to define is the file name. For keeping the original file name equals models.car field. Let's say the max length is 255. We also need a field to keep the actual file. Let's call it upload equals models.file field. Then we can specify the directory where the file is stored. Let's call it uploads. We can get the name of the file uploaded from the upload field, but we can't depend on it because if a file with the same file name is uploaded, a random string is added to the name. Now let's move on to thumbnail. Thumbnail equals For every video uploaded, we want to generate a thumbnail from the video. Let's say models. We can specify the directory where it is uploaded to be thumbnails. Blank equals true and null equals true. Blank and null needs to be true because we don't have a thumbnail when an object or a model instance is first created. Next, we need the preview. Remember that we want to generate a 10-second preview from a video. Let's say models.filefeed upload to be previews. We also need blank true and null true since we don't have an initial value when an instance is first created. Null true. We need a field for the original size of the file uploaded. Original size. Let's make this a float field. Float field. Let's provide a default value to be floats and blank can be true. Whenever you specify the default arguments, you can either pass a real value or a callable. A callable is called every time you create an instance of the model. We also need to track the size after a file has been compressed. Let's say new size, new_size equals models.float field. The default value can be a float and blank also true. Next, we would also like to track the status of the compression. Let's call it compression status _status equals models.carFeed. Let's say default value to be pending. It makes sense to define choices for this field. Choices equals. Let's create a new module where we can keep the choices enums.py from Django DB imports models. Now we can represent the choices as a class. Class compression status. It inherits from models.textChoice. Text choices. Then we can say the default value to be pending. We can also say converting. We also need a status for when the compression is done. Let's say completed. And finally, let's say cancelled. That's if there is an error. Now let's go ahead to make use of the choices in the models. From this same directory.enums imports compression status. Now we cannot say the choices to be compression status dot choices, and the default value should be dot default. Let me format the documents. We also need to capture the duration of a video. Let's say duration equals models.carFeed. Max length to be, let's say, 20 and blank equals true, null equals true. Then the MIME type, which is the type of the uploaded file, models.carFeed. Max length, let's make the max length to be 50. We don't need blank true and null true for MIME type because we know the type of the uploaded file when an instance of this model is to be created. Let's also specify the string representation method, str. For the string representation, let's make it to return the file name self.filename. We also want to specify the default ordering for the model. Meta ordering equals a model feed. This will sort in descending order, meaning the most recently created object will appear first when querying the database. One more thing we should do before moving on is to define a method which converts bytes to kilobytes or megabytes. Let's say def convert bytes. This type of method shouldn't be an instance method because it doesn't need to operate on a specific object. It is more like a utility function. Let's make it a static method at static method decorator. It takes the size to be converted as a parameter and the type is an int, an integer. Also, we need the unit, which can be kilobyte or megabyte. Kilo or megabytes. Mega. Let's make use of literal from typing. From typing, import literal. Now we can make use of this literal, string literal. What that means is that the unit is expected to be kilobytes or megabytes. Then we can specify the conversion rates. Let's say rates, a dictionary, kilo, 1 byte equals 1000 kilobytes, and also megabytes. This is 1 million. Let's say units in decimal. Then we can say the result equals the parsed size divided by the rates. Rates.get the parsed unit. If the parsed unit cannot be found in the rates, let's specify a default value to be megabyte. That is, we should convert to megabyte by default. We can also specify the default value for the units here to be megabytes. Now we want to convert the result to 2 decimal places. Let's say formatted result equals f strings result 2 decimal places. Then we can say return floats of formatted results. One more thing we should add is the owner of the uploaded file. Let's say user equals. Let's keep it simple by representing the user as a car feed. Remember that we are not handling user authentication. Models.carFeed 255. The next thing to do is to validate the media uploaded by users. This can be done by passing a list of validators to the field. As you can see, the validators are expected to be a list of callable. Let's check the documentation. The validate function takes the field argument as the value. As you can see, this is how it is used in the field. Now let's move on to the implementation. We are going to create a new file or a new module called validators.py. First, we need to import the validation error as used in the documentation from Django.core.exceptions import validation error. Now let's create a class to contain the necessary functions or methods needed. File validator. The first method is going to validate the file extension. Validate file extension. Let's make this a static method at static method. Then we want to pass the value, which is the file uploaded by the user. File object. The type of the file object is uploaded file. Let's import that from Django.core.files.uploaded file import uploaded file. Now let's make the type to be uploaded file. Extension ext, which is of a string data type, equals. From a file object, we can get the name of the file, file object.name, and from the name, we need to extract the extension. Let's make use of the OS module to do that. Imports OS. Now we can use the OS module function os.path.split extension. The split ext function splits the extension from a path name. It returns the root and the extension. So the extension is at the index of 1. Then we can say if extension dot lower not invalid extensions, which is a variable we are yet to create. Pass. Let's create the valid extensions. This is going to be a list .mp3.wave then .aac. All these are audio extensions. For video, we have .mp4, .mov, mkv. This is for a video file. We also have .web. If extension, not invalid extensions, we want the user to know the valid extensions. Allowable extensions equals. Let's join the items in the list. Join then valid extensions, then raise validation error. F strings, your file must be one of the following allowable extensions. Let me format the document. Let's write the second method which validates the file uploaded. Let's say def validate file size pass. This is also going to be a static method, file object, and the type is uploaded file. We can know the file size equals file objects dot size. The uploaded file has a property known as the size. Now we can say if the file size is greater than, we need the maximum size that can be uploaded. We've already defined that in the settings file, which is 250 megabytes. Let's copy this variable max upload size. But before we can make use of this max upload size variable, we need to import settings. Let's say from django.conf import settings. With these settings, we can pick a variable defined in the settings file, settings.maxUploadSize. If the file size is greater than the max upload size, then we want to raise an exception. But before we raise an exception, let's calculate the max allowable size in megabytes. Let's say max underscore allowable megabytes to be settings dot max upload size divided by, remember that the max upload size is in bytes, so we want to convert it to megabytes. Let's copy this, then we can say divided by this value, which is this, which is the size in megabyte. Then let's raise an error, raise validation error, and the error is going to be f strings allowable file size. Then we want to mention the max allowable size, max allowable in megabytes. I'm going to format this document. I want to sort the imports. Let's make use of these validators in the models. So we can say from .validators imports file validator, validate file extension, and also file validator dot validate file size. I'm going to format this again. Alright, currently our models is in good shape. Now it is time to execute the make migrations command. There is a warning from the development server. Car feeds must define a max length attribute. Let's check the compression status. Okay, so we need to specify the max length. Let's make this to be 25. Also, there is another error here which says ordering must be a tuple or a list. This is expected to be a list or a tuple. The development server is working as expected. Now we want to run the make migration command, docker compose exec the API service and Python manage.py make migrations. Okay, great. A new migration file has been created. Now we want to run the migrate command, migrate. As you can see, a new migration file has been created. Alright friends, the next thing we want to work on is the views. We are going to use the model view set class. Let's import that from REST framework. From REST framework dot view sets import model view sets. Let's create the media file view set class media file view set. It inherits from model view sets. Model view sets. A model view set provides default operations like creation, retrieval, updating, and deletion. This means a CRUD endpoint will be automatically generated. Let's mention the query set. Let's say query set equals media file. We need to import the media file from the model. From .models imports media file. So the query set is going to be media file.objects.all. We also need to mention the serializer class. Serializer class equals list media serializer. We will define the serializer shortly. Permission classes is allow any. Let's import that from REST framework permission from REST framework.permissions import allow any. We want everyone to be able to interact with the endpoints. Also, we need the HTTP methods equals a list. This is going to be get and post. Remember I mentioned earlier that model view set provides all these operations, but in our case, we only need get and post requests. Get for listing and retrieving, while post for creating a new object. Let's go ahead to create the list media serializer class. We're going to create a new file. Let's call it serializers.py. First, we need to import serializers from REST framework. From REST framework, import serializers. From this same directory .models, import media file, which is the name of the model. Now let's create the list media serializer. The list serializer is going to inherit from model serializer. You use model serializer if you want a serializer class that maps closely to Django model definitions. That's why we must specify the model class method. The model equals media file, which is the imported model, and the fields. We need most of the fields we have here. So first, we need to specify the ID. We need the user. We also need the original size and the new size. We also need the MIME type, the preview, the file name. We also need the compression status, the duration. We need the created at. We've not mentioned the thumbnail. One more field we can add here is the URL field. Let's say URL equals serializer.method feed def get URL self. The object, the type of the object is media file. Media file, it returns a string, which is a URL. Now we are going to return the URL. Let's go ahead to define a URL method on the model. Let's define the URL method def URL. This is going to be an instance method self. It needs to be an instance method because we need the URL from an instance. It returns a string data type. Then we want to say if self.upload, that is if an upload is present, the URL of the upload self.upload.storage.url self.upload.name to return the URL of the upload. This check is important because a file may not exist since we intend to delete the original files after every compression process. Now let's make use of this method in the serializer. Now we can make use of the method in this getURL object.url. Let's go back to the views. From .serializers, import list media serializer. The next thing is to link the views to the URLs. Let's create a new file called urs.py. We need to import a couple of functions and classes from Django.urls import include and path. From REST framework .routers import default router. Also from this same directory .views import media file view set. The name of the app equals compressor. Then we can say router equals the default router. Then we want to register the app router.register. This is going to be the prefix of the path. Then the views media view sets, media file view sets, URL patterns equals path include router.urls. The next step is to register the app URLs in the project URLs. Let's look for the project URLs, which can be found in course, then urls.py. Let's make use of path. The route string is going to be API/v1/files. Then we want to include the set of URLs defined in the compressor app, compressor.urls. If we click on this, then it takes us to the URLs defined in the compressor app. Now let's visit the documentation to see what we have so far. Let's reload this documentation. There is an error. The field URL was declared on this serializer, list media serializer, but has not been included in the fields option. I forgot to include the URLs field in the serializer. We are meant to include this URL as part of the fields. Now let's visit the documentation again. Great, it works. We have an endpoint for listing all the files uploaded by a user. We also have an endpoint for retrieving a file given an ID of the file. If you notice, the post request is using the default serializer we defined on the view sets. We need to correct that when we start implementing the actual file upload functionality. One more thing I want to do on this API is to update the API so that it only returns files based on the user in the query param. Let's go ahead to fix that. Within the view sets, we need to update the getQuerySet method. Let's say def getQuerySet query sets. So within this query set request, and the type is request, let's import the type from REST framework. From REST framework dot request import request self dot request. Now we want to get the user from the query param. The user is going to be a string equals request dot query params dot get user. If not user, that is if no user is present, then we want to say return getQuerySet.none. Otherwise, we want to say return super.getQuerySet.filter by the user. User equals user.lower. If no user is passed in the query param, we want to return an empty result. Otherwise, we want to filter the query set based on the passed user. Let's also override the list method and the retrieve method. We want to document the API so that the query param is shown on the documentation. First, let's import extend schema from DRF spectacular.utils. Import extend schema. Also, we need to import the OpenAPI parameter. So now we can make use of the extend schema as a decorator there. Extend schema. So we can pass a couple of arguments, parameters, request, response. Let's pass the parameters and this is going to be a list of OpenAPI parameter user, and the type is string OpenAPI parameter dot query. We also want to make it required equals true. Let's do the same for the retrieve endpoints. Let me format the document. Now let's check the documentation again. Great, as you can see now, the user is now specified as a query param in the API. What that means is that we need to specify the user before we can try out the API. The same goes for the retrieve endpoints. The user is now required. Now let's start the file upload implementation. We are going to override the create method. The create method is responsible for the post request on this view set. Let's override the create method. Def creates a pass. The request type is requests, which is imported from REST framework. Now we can say serializer equals, we are going to define a new serializer. Let's call it upload media serializer. Then the data to be passed for validation is going to be the data coming from the request.data. With this upload media serializer, we are going to validate the incoming data from the client. This is a good time to define the upload media serializer. Let's do that in the serializers module. Class upload media serializer. This serializer inherits from model serializer. Class meta. Then we need to specify the model equals the media file imported. Then we want to specify the fields we need. In this case, we only need the user to specify the upload file. We need to capture the name of the user and the file being uploaded. Then we can override the create method def creates on this serializer class. You get to access a validated data on the create method, and the validated data is a dict, which is a dictionary. You might want to ask that, how do I know that all these methods exist? Well, what you can do is to visit the documentation, which is the DRF documentation, or visit this website, Classy DRF. On this website, I'm going to drop the link. You can find the methods and attributes available in a class. So now we are on the model serializer. You can see that we have the create method there. We also have other methods, such as the validate method, as you can see here. We also have the update methods. Let's retrieve the uploaded file from the validated data. Let's say file underscore uploaded equals validated data dot get. We want to get the upload, which is this field. The type of file uploaded is actually uploaded file. Let's import that from Django.core.files.uploaded file import uploaded file. We can say the type of file uploaded is uploaded file. Let's declare a new variable data equals a dictionary original size underscore size to be the file uploaded dot size. A file uploaded has the size property. We also want to capture the original name of the file. Let's say file underscore name equals file uploaded dot name. We can also capture the MIME type to be file uploaded dot content type. We also need the user. The user is coming from the validated data dot gets the user. Remember, we are capturing the user from here. So now we can specify the user here. And finally, the file itself, upload, is the file uploaded. Remember, the file uploaded is from the validated data. One more thing we should do on this user is to convert it to a lowercase dot lower. Let's print something on the screen. File data to be the captured data. Then we can say new instance equals media file dot objects dot creates. Then we want to pass the data, return new instance. These double asterisks mean that keys and values from this dictionary should be packed as parameters and arguments. Let's go ahead to finalize the views. We need to import the upload media serializer from the serializers. Upload media serializer. Serializer dot is valid to validate what the user is sending. Raise exception equals true. Whenever you call the isValid method on a serializer, the validate method defined in the serializer is called. We didn't specify the validate method because a model serializer class has the validate method by default. You only override the method if you need to do something specific. Then we can say instance equals serializer dot save. Serializer dot save will call the create method, which is this method we have here, and it returns what you've specified as the return value in the create method. Now let's return the created instance back to the client. Response. We need to import response from REST framework. From REST framework dot response import response. Then we can say list media serializer. Then we need to pass the instance that was created dot data, and the status code is going to be 201 when something is created. Now let's check the documentation again. As you can see, the API doc is still referencing the default serializer we specified on the view set. We can resolve this by using the extend schema at extend schema. Then we can pass the request to be upload media serializer, and the responses 200 status code 200 to be list media serializer. So this is one way of fixing it. Let's refresh the page. Whenever you want to upload a new file, you need to mention the upload and the user. The second way to fix it is by overriding the get serializer class. Get serializer class. Then we can specify the upload media serializer. The third API we need is for getting the statistics on the dashboard. Let's define a new endpoint. Let's say def start request, which is of request type pass. Let's use a custom action from REST framework. From REST framework dot decorators import action. Within this action decorator, we can pass a couple of arguments. First is the methods. This is going to be for a get request, and also for detail, this is going to be false. Detail determines whether this action applies to instance. The URL path starts. Within this method, we want to capture the user, which is of a string data type, dot request dot query params. We want to get the user from the query params. If not user, that is, if no user is present in the query params, let's return response, the detail, empty user query param, and we want to return a status code of 400. Otherwise, we want to say query set QS equals media file dot objects dot filter. We want to filter all the files belonging to this user. User equals this user dot lower. We want to convert the string to a lowercase. We need the count of all the uploaded files. We can make use of count from Django models. From Django .db.models import count. We can also import queue for query. Let's say a new variable uploaded equals count. Count all the IDs, and also compressed equals count. For the compressed, we want to count the IDs of the compressed files. Let's say filter, then we want to make use of queue. We want to say compression status, compression underscore status. Let's import compression status from the enums. From .enums import compression status. We can make use of the compression status here. Compression status dot completed. So this is going to count all the completed files. We also need to count the failed files. Equals, we can just make use of this as well. But in this case, the status is going to be cancelled. Then we need in progress equals count ID. And we want to filter queue compression status underscore status in a list, and the list is going to be compression status dot pending, which is default value, dot converting. Then we can also say data equals query set, which is this query set, dot aggregates. The argument you pass to the aggregate method describes the aggregate value that you want to compute. Uploaded should be this value, which is uploaded. We can do the same for compressed. Compressed equals the compressed value failed to be the result of this failed. We also need to do that for in progress equals in progress. The aggregate method returns a dictionary. In this case, the keys are uploaded, compressed, failed, and in progress, while the values are their values. Let's print the start on the screen. Start data to be the data. Then we want to return a response to the client. Return response. Data equals sources equals true, and the data should be the data. Let's make the response to be 200 status code. Let's add a query param to the documentation. Let's copy what we have here. Then we can add it on the stats. I would like to provide a sample response in the documentation. Examples. We can say this to be OpenAPI example. We need to import that from the DRF. OpenAPI example. We can make use of the OpenAPI here. And in this example, we can say the name to be start example. Let's say dashboard, and the value is going to be a dict, which is sources equals true, and the data is going to be a dictionary. Uploaded 0. For compressed, the value is also 0. Failed, the value is 0. We have the in progress. Let's provide a default value of 0. Let's format this document. Now let's go ahead to check the documentation. This start is meant to be under the files. Let's check what we have done wrong. We are meant to put a slash here. Let's check the documentation again. Let's test the endpoint to retrieve all the files. Let me specify the username as Ray. The result is 0. Let's check the post endpoint. The application type to be form data. I'm going to specify the user as Ray. Let's choose a file which is an image. Let's execute the program. Great. This shows that the validations are working. Your file must be one of the following. Let's choose a file which is more than 250 megabytes. Now let's select this file, which is a video. Let's execute the program to see what happens. The validation works. Max allowable file size is 250 megabytes. Let's choose a file which is not up to 250 megabytes. I'm going to select this audio file. Now let's test that out. There is an exception. 403 response. This response from AWS is because we don't have the correct credentials. In the next section, we are going to set up AWS S3 buckets to store user uploaded files. In this part, we are going to create an AWS S3 bucket. You can sign up for a free AWS account valid for 12 months if you don't have one. I'm going to click on the services, then S3 buckets. Click on the create bucket button. The name of the bucket is going to be Compressor. Select ACLS enabled. In our case, we want public access to this bucket. So I'm going to uncheck this box. Click on the create bucket button. As you can see, we have a newly created bucket listed here. The next step is to create a user with access to this bucket. Let's go to the IAM service. On the IAM service dashboard, click on the users tab. Now click on the create user button. I want to specify the name of the user. Let's say Compressor bucket user. Click on the next button. Click on attach policies directly to attach permissions to the user. So let's search for S3 full access. Alright, so this is the permission we want to attach to the user. Click on the next button. Finally, click on the create user button. As you can see, we have a new user listed. Now let's click on the compressor bucket user. Under the security credentials, we want to get the access keys needed by this user. Click on the create access key. So we want to select the purpose of this access key. I'm going to select local code. You plan to use this access key to enable application code in a local development environment to access your AWS accounts. Now click on the next button, create access key, then create access key. The access key needed by this user has been successfully created. This is the access key and this is the secret key. Make sure you don't reveal this secret key. For the access key, I'm going to copy it. Then I'm going to go into the code. You need to specify the access key here. Make sure you put your own access key in the .env file. I put it here because I don't want to rebuild the container. AWS secret key. I'm going to copy the secret key. We need to copy the secret key. I'm going to put it here. And finally, AWS bucket storage name. The name of the bucket is the name you specified while creating the S3 buckets. In my case, the name is Compressor. Now let's try out the post request. Let's try out the endpoints. Great, we received a 201 response code. This is the ID of the created file. This is the user and this is the original size. So let's check out the terminal. File data, which is the original size, the file name, the MIME type, the user, the upload. So this means the file has been successfully uploaded to S3 buckets. Let's confirm that in the S3 bucket. I'm going to navigate into the buckets, and under the media we have the uploads folder. This is the audio file we just uploaded. With this ID we can retrieve the file. Let's make use of the detailed endpoints. We need to specify the ID, which is the UUID, and the user is Ray. Let's try that out. It works. One more thing I want to do on the serializer class is to convert the original size to megabytes. Let's make use of the media file dot convert bytes. The convert bytes method needs the size and also the unit. So this means the original size will be in megabytes. Alright friends, the next thing we want to do is to work on the compression implementation. If you check the select section in the container, you would see that no tasks are registered. Let's create a sample task to ensure that Celery has been configured correctly. I'm going to create a new file called tasks.py. We need to import shared task from Celery. From Celery, import shared task. Now, let's create a sample task. Let's say def sample task, a function as a pass. Then we need to decorate it with @shared task. For Celery to recognize this function as a task, we need to decorate it with shared task. Let's go ahead to check the container again. We now have the task registered as a Celery task. Compressor is the name of the folder and the name of the modules and then the name of the function, which is sample task. Celery is able to auto-discover tasks because of the configurations we've specified in the celery.py file. Auto-discover tasks. First, we installed Celery. As you can see in the requirements file, we have Celery listed. Then we have a configuration file for Celery, and also in the installed apps, we mentioned the configuration. Let's look for the installed apps. This is the Celery config. Now, whenever a new file object has been successfully saved in the database, we need to trigger an event to start the compression process. This is where Django signals come in play. Let's create a new file called signals.py. We need to do a couple of imports from django.db.models.signals import PostSave. From Django.dispatch import receiver. From this same directory.models import the media file. Let's create a function called initiate media compression. Def initiate media compression pass. Then we want to decorate it with @receiver PostSave and the sender equals media file. What we are saying here is that after a media file has been saved, we want to call this function. That's why we mentioned PostSave. That is, after a media file object has been saved, we want this function called. There are other signals available. As you can see, we have post-delete, post-init, pre-save, and so on. In our case, we need the post-save signal. This function takes a couple of arguments: sender, instance. The instance is of the type of media file, which is the model. Then we have created and also some keyword arguments. The created argument will be true if this is the first time the object is created. If created, we would like to know the type of the file. Let's say file type equals instance.mimetype.splits. Remember that the MIME type is always of this format: video MP4, audio MP3. We can use the split method on a string to know the actual type. Index of 0 will be the actual type. Then we can further do some checks. If file type a list of audio and video, then we want to start the compression process. Compress media upload dot delay. We are yet to define this Celery task. Instead of using a nested if statement, we could use the AND operator to combine the two conditions. File type to be this. Then we can say if created and file type in audio or video, then we want to execute this function, which is a Celery task. Let's go and create this Celery task that will undo the compression process. Let's go into the tasks.py. Then we can define a Celery task as this: compress media upload. In these signals, we can save from .tasks import compress media upload. Whenever you call the .delay method on a Celery task, Celery handles the execution of that task asynchronously. Celery places the task in a message queue to be processed by Celery worker processes. The application will continue to run without waiting for the task to complete. There are a couple of arguments we would like to pass to this function. First is the name of the file from AWS. Let's say instance.upload.name. We also need the ID of the upload, instance.id, which is the identifier. Also, we need the file type. Now, let's move on with the compressed media upload task. Upload name, which is of a string data type, and also the media ID from UUID imports UUID. So the type of this is UUID, and the file type, which is a string data type. So this function is going to contain the compression implementation. We want to compute the durations of uploaded media, generate a video thumbnail, and provide a video preview. Additionally, we would like to compress both audio and video. For now, I'm just going to create a helpers module to contain those functionalities. Let's create a new file, helpers.py. Let's create a class for those functions, class media helpers. The first method is going to be compute duration pass. This is going to be a static method. Also, we need another method called generate video preview. Generate video preview pass. This is also going to be a static method. Also, we need the generate video thumbnail. Def generate video thumbnail compress underscore video at static method, and also def compress audio at static method. I have a complete course on object-oriented programming if you are interested in delving deeper into OOP in Python. Now let's outline our implementation plan. Whenever a new file is saved to the S3 bucket, our objective is to download the file to a unique directory on the system. Subsequently, we will initiate any further operations from that unique directory. So we need a way to connect to the S3 bucket. Let's create a new file named utils.py. Let's import the necessary modules. Imports boto3, which is used to connect to AWS. Let's say from Django.conf import settings. We need the credentials from the settings file, so we can say access key, access underscore key equals settings dot. In the settings file, let's look for the credentials base.py. Let's go back into the utils.py, and also we need the secret equals settings dot. The secret from AWS, we need the secret key. So let's go back into the utils.py. Also, we need the bucket. Bucket equals settings dot. The bucket from the settings file. Let's go back into the utils. We can now say options, which is going to be a dictionary. AWS access key ID to be the access key we declared. AWS secret access key. The secret. Now let's create a class for S3 manager. This manager class will establish connection to S3. Let's say class S3 manager. Then the init method def init. So we want to say self.s3 equals boto3.client. We want to connect to S3, and we need the credentials options. This is going to establish a connection to the AWS S3 bucket. Also, we need self.manage bucket name to be the bucket. The first method will download a file from S3 to a particular directory on the system. Let's name that method download original media from S3. Download original media from S3. This can be an instance method since we need to access these attributes. It takes the first parameter as self. It also takes a temporary directory. This temporary directory will be the folder where the file is downloaded to. This is going to be a string data type. We also want to pass the key of the file we want to download. Any object created on S3 has a key. Let me show you that. As you can see, the previous file we uploaded has a key. We also need the actual media from Django. So we need to import the media file from the models from .models import media file. Now we want to create a temporary file. Let's import the named temporary file from the temp files module. Let's import that from the temp file module. From temp file, import named temporary file. So we want to create a temporary file using named temporary file, and we can specify the directory to be the directory passed. Let's say temp directory. Also, we can specify delete to be false. Delete equals false means that the temporary file should not be deleted when we exit out of the context manager. So we can say this as temp S3 file. Within this temporary file, we want to download the file from S3 into it. Let's look at the documentation to see how that can be done. We can make use of download file object. Download an object from S3 to a file-like object. This means if we have a file opened, we can download an object from S3 into the opened file. So let's make use of this method, self.s3. This method, then we want to pass the name of the bucket, self.bucket, and also the key of the file we want to download, and finally the opened file, which is where we want to download the S3 file. So let's specify this as temp S3 file. Once we have an S3 object downloaded into this file, the first thing we want to do is to get the duration of the media. So this is where we need the helpers module. We can say media dot duration equals the helpers module. Let's import the helpers module from dot helpers import media helpers dot compute duration. So we need to pass the file to the compute duration method. The name of the file is the same as the location of the file. When you get the name of a file from named temporary file, it returns the file path. Then we can say file underscore path. I have installed the ffmpeg library on my machine. So this command returns the duration of a media. This duration is in seconds. If you check the Docker file we use, let's look for the Docker file. We have the package installed in the container. So we need a way to execute a command on the operating system from the Python program. This is where the subprocess module comes in handy. It makes it easy to integrate other programs with your Python code. We need to import the subprocess module. Import subprocess. Then we can specify the command as a list. Let me copy the command from the notepad, Ctrl C. So we need ffprobe, the input -i. Then we need the file path. Also we need the show entries. We also need the format, which is duration -v quiet -of, and the format, which is CSV. -I signifies the file input. Show entries specifies the information to be displayed. In this case, we set it to be the duration. This flag suppresses unnecessary output from ffprop. And finally, the output will be formatted as a CSV with no header. Now let's use the subprocess module to execute this command. We can say results equals subprocess.run. Then you can pass the command to be executed, capture output to be true and text to be true. So we can say if result.return code equals 0, which means everything is fine. Results.std output .strip. Let's convert the returned string to seconds by using the datetime module. Let's import datetime module. From datetime, import time data. Now we can convert this to seconds. We need to make use of time data, and seconds to be this. The returned value will be in this format, which is 0000. We can also remove the dot part from the outputs. Cleaned duration equals, let's convert the duration to a string data type, str. Now we can say cleaned duration equals duration, which is a string, dot splits. Then we want to index of 0, which is the first part. Now we can return the cleaned duration. The file path is a string data type, str. It returns a string data type. Let's go back into the utils.py file. Immediately we compute the duration. We want to set the media.status, let's say compression status, from .enums import compression status. So we want to say at this point, when the file has been downloaded and we've computed the duration, then we can set the status to be converting, compression status dot converting. Then we can update the media object, media.save. We want to update the duration and also the compression status. Let's make this method to return the downloaded file, that is the path of the file .name and the media itself. Let's print something on the screen. We can say print this. File was downloaded. Now let's say the name of the file, temp file.name, which is the path of the file. Let's specify the type of the returned value to be a tuple and the media file. Let's say media file. I'm going to format this document so that you can see everything. I would like to put this method in a try and except block. Accepts exception as error, print error downloading objects. Let's say string of the error. Let's raise an exception at this point. Raise exception, and the content should be error downloading from S3. The key. This is a good time to implement other methods in the helpers module. Let's work on the generate video thumbnail. We need the input file path, which is a string data type. The input file path is the downloaded file. Also, we need the output folder, output underscore folder. The output folder is going to be the directory where the thumbnail is created. Let's say a string data type. Then at what length in the video should the thumbnail be generated? Let's make it 10 seconds by default. Let's say time stamp to be a string data type, and the default value is 5 seconds. I have tried out this command, which generates a thumbnail from a video. As you can see, the input is oop.mp4 at 5 seconds and the frame is 1, and the generated thumbnail is this. Let's execute the program. Let's see the generated thumbnail. This thumbnail is generated from the video. Let me copy the command from the notepad. Thumbnail path equals the output folder, which is the directory where the thumbnail is generated, and the thumbnail.png. Now we can specify the command equals a list. We need ffmpeg ffmpeg and the input -i, the file path, which is the input file, the frame, and also we need the thumbnail path. We can say result equals subprocess.run to run this command. Check equals true, text equals true. If results.return code equals 0, then we want to return the thumbnail path. Next, let's work on the generate video preview. Let's copy the command. I'm going to try out that command here. The input is oop.mp4 and the timestamp should be 0. We want to generate the preview from 0 second to the 10th second, and the name of the preview file is preview_oop.mp4. Let's execute this command. Now let's check the folder to look for the preview. We have the preview here and the size is 10 seconds. Let's play it. Object-oriented programming, also known as OOP, is an important concept in programming. It works. So we can make use of this command in our code. Let's put the command here. First, we need the input file path, which is a string data type. We need the video name, video_name. We want to use the video name to generate the name of the preview version. This is going to be a string data type. And also we need the output folder, which is the directory where the preview is created. This is going to be a string data type. Let's format these documents so that you can see the screen. Also, we need to specify the start at. This is going to be a string, and the default value is going to be the actual start of the video. Let's say video preview path, video preview _path, f strings, output folder / video _preview _video name .mp4. Now we can specify this command equals a list ffmpeg. The input is the input file path, and also we need the start. Let's say -ss to be the start at, and the stop should be 10 seconds. At the 10 seconds, video preview path 10th second from the start. Now we want to use the subprocess module to run this command. Check equals true and text equals true. If result.return code equals 0, then we want to return the video preview path. Now let's work on the compression methods. The achieved compression level largely depends on the bitrates, frame rate, and presets. I distinguished between the two methods since distinct parameters may be applied for audio and video. So we are going to keep it simple by using the default values. For the compressed video method, let's specify the input file path, input underscore file underscore path, a string data type, and the video name. And also the output folder, which is the directory where the compressed version is located. This method returns a string, which is a file path. Then we can say compressed video underscore path f strings, the output folder slash compressed version underscore video name dot mp4. Then we can make use of the command equals ffmpeg. The input is going to be the input file path, and the output is going to be the path of the compressed video path. You use this command to compress a video or an audio, the input file and the output file. Let's say result equals subprocess.run. We want to pass the command check equals true, and also we can say text equals true if results dot return code equals 0. Then we want to return the compressed video path. Let's do the same for the compressed audio method. We need the input file path, which is a string data type. We need the audio name, audio underscore name is also a string, and also the output folder, outputs underscore folder, to be a string, and the return type is also a string. Let's say compressed audio underscore path f strings, the output folder slash compressed version underscore audio name dot mp3. Then we can now specify the command equals a list. First we need the ffmpeg and also the input file. The input file is going to be input file path, and the output is going to be the compressed audio file path. Let's say result equals subprocess.run. We want to run this command, and check equals true, text equals true. We can say if results dot return code equals 0, then we want to return the compressed audio path. We have the needed methods in place: compute duration and also generate video thumbnail. We also have compressed video and compressed audio. Let's see how we can use these methods in the Celery task. Remember I mentioned earlier that for each user uploaded file, we need to create a unique temporary directory. So we want to use a concatenation of the file name and a random string as the name of the directory. The upload name of a file is of this format: uploads/sample.mp4. We can get the base name by using the OS module from os.path imports base name. So we can say base underscore name, which is a string data type, equals base name, and we want to pass the upload name to it. So this is going to return the base name, which is the actual file name. The base name will return sample.mp4 in this case. From the base name, we want to get the name of the file, file underscore name, which is also a string data type, equals base underscore name dot splits. The split method on the string will return a list containing sample and mp4. So we want to get mp4, which is at the index of 0. The name of the directory for the file, directory name, equals file name plus, now we need a random string. Let's make use of the crypto modules django.utils.crypto import get random string. So we can make use of this get random string to return a random string, and we can specify the length to be 8. So with this approach, we are trying to create a unique name for the directory. We don't want to rely solely on the name because this name can clash with another name but different extension. Now we have the directory name. Let's also retrieve the media object from the database. Let's say media_object equals, let's import the models. From .models import media file. Now we can make use of media file here. Media file.objects.get id equals the media id passed. We have the media object. Let's create a temporary directory for this file. We need temporary directory from the temp file. From temp file import temporary directory. Temporary directory, that is, we want to create a temporary directory, so we can pass the prefix. Let's say prefix. The prefix is going to be the unique directory name as temp compression directory pass. Let's put this in a try except block. For now, let's say pass. Now we need the media key for us to be able to download the file from S3 bucket. Let's say media_key equals, every file is saved in a directory known as media / the upload name. Let's take a look at an example in the S3 bucket. We have media as the initial directory, then uploads, the name of the file. Then we can now make use of the S3 manager, which is in utils. From .utils import S3 manager. The S3 manager has a method called download original file from S3. Let's say S3 manager.download original media from S3. We need to pass the temporary directory, the key of the media, and also the actual media itself. Let's pass the temporary directory. Temp directory is going to be temp compression directory, which is the directory we are creating here. We need to pass the key. The key equals the media key. We need the media, which is the media object. Media equals media objects. This method returns the path of the downloaded file and the media objects. So we can say downloaded file path and the media equals this. The method returns a tuple, downloaded file path and the media. Now let's use the match case statement. Match file type case video. We want to do something, and also if the case is audio, we want to execute this block. Otherwise, let's provide the default case. We want to raise an exception. F strings unsupported media type detected, and the media type is the file type. For a video file, we want to generate the thumbnail. Let's import the media epass from .helpers import media epass. This media epass has a method known as generates video thumbnail. For us to generate the video thumbnail, we need to pass the input file. The input file is the downloaded file path. Also, we need to pass the output folder. The output folder is the directory where the generated thumbnail will be saved. So the output folder is going to be this temporary directory we are creating here. Temp compression directory. This method returns a file path. So we need to open the file and save it as the media thumbnail. Let's open the file by using a context manager with open. We want to open the file path returned from this method. With open this file, we need to open as binary argb thumbnail file, thumbnail underscore file. Let me format the document so that you can see everything. So when this file is opened, we want to save it as the media thumbnail. Let's say media.thumbnail. This method, which is an instance method, is not returning the correct type because we are calling an instance method without instantiating the class. So let's instantiate the class before we can call this instance method. Now let's say media.thumbnail. Let's also rename this to be thumbnail equals the thumbnail file open. But before we can do this, we need to convert this opened file to a Django file from django.core.files.base import file. Now we can make use of the file class here. We need to pass the file object and also the name. Let's specify the name to be base name. We want to extract the actual name of the file from the opened file. Let's make use of the base name to get the actual name of the file. So this is going to return the actual name of the file. Now let's save the media object, media.save. Let's check if everything has been set up correctly before trying out the endpoints. Let's look at the signal whenever a new file is created and the type is audio and video. Let's check the app. For the signal to work, we need to register the signals when the application starts. So let's use the ready method for that. Def ready import compressor.signals. Now let's try out the post endpoint. Try it out. Then I want to select multipath form data. Let me specify the name to be array. Let's choose this video. Now let me execute it. Great, we have a success response. Let's check the terminal. The Celery action shows that a new task is received. There is an exception raised by Celery, error downloading objects, unsupported type for time data seconds. Let's check the compute duration method. The passed seconds is expected to be a float, not a string. Let's convert the string to a float. Now let's try out the endpoint again. We have a 201 response. The Celery task shows that a new task has been received. File was downloaded. This is also the temp file. So we have this process completed successfully. Now let's make use of the returned ID to query the file. Ctrl C. Then I want to try out the get files by ID. Try it out. The user is Ray. Now let's try this out. Let's copy the URL to visit the link. Great. This means the thumbnail was generated and saved successfully. Now let's go back into the task modules. The next step is to generate a video preview. Let's make use of the generate video preview method. Media.generate video preview. We need to pass the input file path, which is the downloaded file, and also we need the video name. The video name is going to be the name of the file, which is the same as the file name. Let's pass the file name also, file name. We also need the output folder, which is the temp compression directory. And we need the start time. Let's use the default start time. Now, when this video is generated, we want to open the file. Remember, generate video preview returns a string, which is the file path. So we would like to open the file with open. Then we need to mention the file we want to open, which is the path returned by this method. We need to open it in read binary as video preview underscore file. Let me format the document. We are opening the video preview path. Then we want to say media.preview equals file. Then we need to pass the file path, which is video preview file. Also the base name, that is the name of the file, video preview file dot name. Let me check this method. The returned type is a string str. Now let's go back into tags. Now we can say media.save to save the preview. Let's do the same for the compressed video. Compressed video path equals media epa dot compressed video. We need to pass the input file, which is the downloaded file path, and also we need the video name, which is the file name, and also the output folder, which is the temp directory. This method will return the compressed file path. Let's open the compressed file with open compressed video path. We need to open in binary mode, read binary as compressed video. Then we want to say media.upload. We want to replace the original file with the new file. We need to pass the compressed video and the name, base name of the compressed video dot name. We also need the size of the compressed video. Media dot new size equals, we can get the size of the compressed video by using the OS module. Let's import the OS module. From OS, import start. We can get the size of a file using this start function. Let's make use of the start function. We need to pass the file path of the compressed video dot size st size. This returns the size of the file in bytes. We would like to convert this size to megabytes. We can make use of media file, which is the model. Let's look for the model. We have a method called convert bytes, which is a static method. Let's make use of that in the tags. Media file dot convert bytes. So we need to pass this media dot save. That's all for a video file. Let's work on the audio. We need the compressed audio path. Let's say compressed audio underscore path equals media epa dot compress audio. We need the input file path, which is downloaded file path, the audio name, which is the file name. We need the output folder, which is the temp compression directory. Let's open the compressed audio with open compressed audio path. We need to open in read binary as compressed audio. Then we want to say media.upload the new compressed file, and the name. We can make use of base name to extract the name from the file. We also need the new size of the compressed audio. Media.new size equals start compressed audio path dot st size. Now we need to convert this to megabytes. Media file dot convert bytes. We pass in the size and also the unit, which is going to be megabytes. And finally, we want to save this. Let's say media.save. Let me format the document. After the match statement, we would like to set the status of the media object to completed. A media object dot comprehension status equals, we need the comprehension status from enums. From dot enums import comprehension status. Let's make use of this comprehension status. Comprehension status dot completed. If any error occurs, we want to set the comprehension status to cancelled. Let's do that in the except block. Let's say except exception as E as error. Let's print something on the screen. Exception captured. str of E media object dot comprehension status to be comprehension status dot cancelled raise exception f strings, let's say conversion, and upload failed. The error as E. Now let's make use of the finally block. The finally block will always run at some point in your code, regardless of whether an exception is raised or not. Let's say media object dot save the comprehension status. We don't want to depend on the media returned on this line because of any exception that might occur. Let's test out the endpoint again. Let's reload this page. Then on the post request, try it out. Let's choose the file, desktop, and test the video. Let me select this 19 megabyte video. I want to specify the name as Ray. Let's execute that. On the terminal, we have the original size to be 19 megabytes. The file name, MIME type. The speed depends on how strong the internet connection is. Great, we have a 2010 response. The original size is 19 megabytes. And the MIME type is video MP4. Let's check the Celery task. Now we have the file downloaded. File was downloaded at this path. This shows the Celery task is successful. Let's visit the endpoint again. This is the ID of the file. Now let's make use of get file by ID, and the user is Ray. Let's try this out. We have the original size to be 19 megabytes, the new size to be 2 megabytes. The duration is 54 seconds. First of all, let's check the thumbnail. Great, we have the thumbnail working as expected. The length of the video is 54 seconds. Let's check this out. It works. What's going on, friends? List comprehension is a fast and elegant way. This shows our implementation is working as expected. One more thing we would like to do is to delete the original file from S3. Remember that we are not deleting the original file. If you check here, we are only updating the original file. That is, the media.upload should be the newly compressed video. Let's check out the S3 bucket to confirm this. The uploads can be found in this directory. As you can see, this is the initial file uploaded, which is 18 megabytes. The compressed version is 1.9 megabytes. Let's work on getting rid of the original file. Let's go to S3 Manager. We want to define a method here to handle the deletion of the file. Let's name the method delete original file from S3. Delete original file from S3. Self. We need the media key, which is a string data type. Then we want to put this in a try except block. Try, let's say response equals self dot s3 dot delete object. Here I have the documentation opened. Delete object. This method removes an object from a bucket. S3 dot delete object. Then we need to pass the bucket equals self dot bucket name. We also need the key, which is going to be the media key. Let's print something on the screen. Print file deleted. Then we can say except exception as E. Let's print the error on the screen, and exception is captured in delete object. We don't need the response. Let's remove that. Ideally, print statements are meant to be replaced by logging. Let's see how we can make use of this method in the task. Let's create a Celery task to handle the delete functionality. Def delete original media. We want to pass the media key, media underscore key, which is a string data type. The S3 manager, original file from S3. We need to pass the media key. At shared task, we can also say the name equals remove underscore S3 underscore original media. Let's check the terminal to see if the task is now registered. So we have the task registered, remove S3 original media. Now let's make use of this Celery task in the finally block. We have the media key here, so let's make use of the media key. Now let's try out the endpoint again. Let's choose the 19 megabyte video. The name is Ray. Now let's execute the program again. The size of the file is 19 megabytes. The removal task is also successful. File deleted. Let's use the ID of the file to retrieve the file. Ctrl+C, get file by ID. Let's specify the ID and also the user, which is Ray. Now let's go to the bucket to see if the file has been removed. Uploads. Let's sort by size. This shows the file has been removed. This file is the original file uploaded. I would like to document some of the methods before we start the front-end integration. Let's say returns media duration in seconds. The format is this. And also this generate video preview. Let's say returns the temporary path for the generated video preview. The same for the thumbnail. Returns the temporal path for the generated video thumbnail. If you check the endpoint, you will see that we don't have filtering and searching on the get endpoint. That means we need to update the views. We are going to make use of Django filters. We included that in the requirements. So let's make use of it in the views. From Django filters .rest framework, import Django filter backend. We can specify the filter backend, which is going to be a list. Then we can say is Django filter backend. We would also like to include search filter from REST framework .filters import search filter. Let's include the search filter in the filter backend. Let's say search filter. Now we need to mention the search feed, search underscore fields equals, then a list of fields we would like to search. Let's say user, and also the file name, user and file name, file underscore name. Then we need to mention the filter fields. Let's say filter sets underscore fields equals a list. We need the comprehension status. Let's say comprehension status underscore status. Let's check the documentation again to see what we have. Great, we can now filter by the status. Let's try it out. Completed, and the user is Ray. Let's see the outputs. We have 3 completed files. Let's say cancelled, 0 results. Let's filter by pending, 1 result in pending. In the next part, we are going to start the front-end integration. Alright friends, here we have the front-end written in Vuejs with VueRouter. I opted to use the reactivity API for state management to keep things simple. As you can see, we have default values set in the store. Next, we have the views. There are 2 main views, the home view and the dashboard. Once a user clicks on the proceed button, we update the value of the user in the store and navigate the user to the dashboard. Dashboard main contents. Let's take a look at what we have in the dashboard view. Let's visit the all components. For the table results, all the APIs are called when the component is created. As you can see, when a component is created and there is no files in the all files, then we make an API call to fetch all files. We have a function called fetch data. In the API service, we are making a GET request to the specified endpoints. If you check all other components, we are basically filtering based on the status of the files. As you can see, the compression status is completed. Let's check for cancelled. The compression status is cancelled. We are filtering based on the user in the query params and also the compression status. The next component I want to show you is the upload new file, which is where a new file is uploaded. When a new file is successfully uploaded, we increment the statistics value in the store. Also, we update all files and the file in progress. On the terminal, we are using the npm run dev command to start the development server. Let's visit this URL. Let's say Ray. We can navigate to different tabs. This is in progress. If you refresh the page, you are redirected to the home page. Let's take a look at the router. We are using the route guard, which is router.beforeEach. We can also log out, and if I specify another user, let's say Maya, no files. Now let me log in as Ray again. Let's upload a new file. We can use this 19 megabytes. Let's upload and compress. Let's check the terminal. The original size is 19 megabytes and the file name is compressionintro.mp4. Great, the file has been successfully uploaded. As you can see, the previous value of uploaded is 5, now it is 6. The same for in progress, it was 2 before, now it is 3. Let's refresh this page. It is still in progress. Let's check the terminal. The compression is now in progress. The file is now compressed. Alright friends, I hope you find value in the video. Some improvements you might want to consider include adding automated testing to the application. Be sure to check the link below for a PDF guide to get you started with PyTest. Additionally, you could consider adding WebSocket support so that the client can be notified when a compression is completed. One way to support me is by subscribing to the channel. Kindly do so and don't forget to like, comment and share. Thanks.